Before I pass you over to my colleague Ian Holdsworth, who will be doing the very last session this afternoon, that starts in about a minute or two. I'll just go over an overview of my colleague's presentation this afternoon. Ian will be discussing some key points, including recording and running a web on web performance test, editing a web, accurate simulations, and dynamic parameters. On the load testing, key points including understanding load testing, creating and editing a load testing, types of performance testing, and running a load test. And after the session, obviously, again, we will have another Q&A session for you to ask my colleague Ian for any questions that you might have on his session this afternoon. So without further delay, I now pass you over to my colleague Ian to discuss the web and load performance testing for this afternoon session.
Last session this afternoon, we're going to be discussing web and load testing with Visual Studio 2012. To start off with, what we're going to cover in the first half is how we actually build the principal building blocks for load test, for actually doing load testing, which is a web performance test. And in the second half, we're going to actually look at taking those building blocks and actually turning them into a functioning test, where you actually simulate multiple users all using the system at the same time. Microsoft, if you're using a test rig with Microsoft's load testing, you have no limitation on the actual number of end users you can simulate. So you can simulate thousands, if not tens of thousands, assuming you've got enough machines to actually achieve that. So, first of all, what we're going to be looking at is we're going to be understanding how the HTTP layer works, because most performance testing is normally done on websites. So we'll be looking at how each HTTP traffic works. Then we'll be looking at recording and amending web performance tests, editing possible errors, and then we'll be looking at creating, running, and analyzing load tests. So recording a web test. The basic thing you really need to understand about a web performance test is it operates purely at the HTTP layer. It's thrown off. It's just doing the network interactions that are associated with a web browser. So it's thrown off all the rendering. It's basically the only parsing it really does is for things like dependent requests, so that it knows that this .js file needs to be downloaded as well. So essentially all it is it's a list of requests and timing information which is recorded in Internet Explorer. It doesn't run any scripting whatsoever, no ActiveXs, no JavaScript. It will simply run as a HTTP interface. It will record what dependent requests a response actually generates, and these it will give you the opportunity of handling individually if need be. Basically, the main use of the web performance test, as I said earlier, is for generating code, so generating load on a website. It doesn't have to be an actual manual user interface. It could be a computer interface, so it could be a web service that you're actually testing, although we won't be demonstrating that particular one today. I think that covers that one. So things that are captured. Query string parameters, form parameters. It will pick up on things like hidden fields at runtime. So if hidden fields actually change, then it will essentially it will identify them at runtime when you're actually running it. So it's hidden fields tend to confuse people a little bit, but they once you get used to them, they're quite easy. Things that are not captured but are still downloaded are things like images, cascading style sheets, JavaScript and other resources. HTML responses will be parsed, but only to actually identify these and download them at runtime. So even if it wasn't a dependent request when you actually made the recording, it will still download any additional ones that are coming up since. Things that will be handled at runtime, I think you'll excuse the police just going past, things that will be handled at runtime are redirects and other things that can be done automatically in the headers. So cookies and that sort of thing will be handled automatically at runtime. So let's go ahead and record a web performance test. First of all, what I'm going to do is I'm going to create a new project. I'm going to make it a web performance project. I'm going to call it training. As you can see, it's created a blank web test for us. So, first thing we're going to do is we're going to actually add a recording. Now, I need to actually explain the differences here. In 2010, what it would have done is it would have taken us straight into the web test recorder in Internet Explorer. In 2012, it just brings us straight into this empty web test. So what we have to do then is actually add a recording. So here in the web test, we've got a number of buttons. I'll just pause it. The record button, the pause button, stop button, the add comment button, and the clear all requests button. If I just put it back on recording, sorry, I have to explain, it does purely operate as an add-in in Internet Explorer. If you have any problems, it's probably been disabled. So you just need to go into the settings in Internet Explorer and re-enable it. If I just click on record and then add a comment, you'll notice that it automatically pauses it. And then if I enter a comment, this renders our web performance test that much easier to read, because otherwise we end up with some pretty indecipherable URLs. So what I'm going to do, I'm going to click on my button to actually load the web page that I want. And as we can see, it's added it into the web performance test. I'll add another comment for my next action. I'm going to click on model aeroplanes. I'll click on it and add another comment, and I'm going to click on fourth coffee flyer. Essentially, this is just, these comments will come up when we actually play back the test. So we will actually be able to see these comments in our results. Right, that should be enough for what I'm actually trying to do at the moment, so I'm just going to stop it there, and it's rendered our web performance test. And the first thing it tries to do is it will run away and it will try and identify dynamic parameters. So these are things like form fields and other query string parameters that it needs to actually pull out of one request in order to be able to actually do the test. And looking at it, I don't think it's actually found any at this stage, but we will be demonstrating that one later on. Okay, so moving on, what we're going to look at now is running web performance tests. Now, when we actually run a web performance test, the results will be collected. There's two panes in the web test results viewer. You've got the top pane, which gives us each individual request and shows us each individual request status, so we can see if a request has failed. We can also see things like how many bytes were in the request, how many bytes were in the response, how long the request took, how long the response took. And also, we can also see things that are going on, like if there's a branching, if there's an if branch, if there's a loop, it will tell us what iteration of the loop it's on. But that's more advanced than I intend to actually cover today. In the bottom panel, we have a number of options. The first one that comes up is the web browser option. Now, the web browser option essentially depicts HTML response in a web browser. Now, this isn't necessarily going to look the same as our web page when we were actually viewing it, because this web browser can only sit at the bottom of the HTTP stack, whereas in an actual browser, these can actually sit at any point within the HTTP stack. So the browser would supersede the stack. It would encompass the stack to a certain extent, if you like. And the stack would be operating within the browser. Therefore, it can intercede at any point. So things like Silverlight, for instance, you will not even render in this browser. Moving on, we've got requests. What requests will give us is more information, so it will give us exactly what was in the request. It will break down certain information, so it will tell us what form post parameters were passed, what query string parameters were passed. It will tell us what was in the header, so what the cookies were and things like that. And then, moving on, we've got the response. Now, the response will basically tell us what was in the headers that came back. This might actually be, more cookie information. There could be more information on how the page should be rendered. Also, you've got the HTML body, which will give us in raw HTML, although it will give us the opportunity to actually view it in an actual HTML editor. Moving on from there, we've got the context view. Now, what the context view will tell us is what session variables we actually have. Now, there'll be some that are automatically put in there by Visual Studio. So you've got some identifying what test agent we're on and identifying other information regarding that test agent. So what virtual user we're actually pretending to be. Essentially, this is any dynamic parameters that we've actually pulled out of a request would be stored in the context so that we can use them. There's transient. Basically, it builds up as we go down. Each individual request can potentially add more fields into the context, and we can then use these fields in subsequent requests as query string parameters, for instance. And then there's the details. Now, the details are to do with a part of this topic that I may be covering today if we have time. I'm going to reserve it for the very end. Essentially, that's to do with extraction rules and validation rules. If we run out of time, I may not be covering this particular section. Essentially, it's just basically saying whether validation rules passed, if an extraction rule was compulsory, whether it passed. And it's just telling us what happened with this individual request. So let's have a look at running a performance test. So essentially, what I'm going to do is I'm going to right-click So I'm just going to go down to run, which will give us the opportunity to actually run the test. I can also come up to the toolbar, and this gives us the option to run the test. We can also debug the test, which we might do if we were, say, overriding certain elements of it, and we can run it or debug it with a pause. Now, what this will give us is the facility to actually single step through each request if we so wish. I'm simply going to press run the test. As you can see, it's gone through them quite quickly at this point. And we can see that the web page is not quite rendering how we saw it when it was actually in the actual browser. We can also see what the HTTP status was, the total time, the request time, the number of request bytes, the number of bytes in the response, and we can also see what the actual status was for each request. Moving down to the bottom, we can see in the web browser that, yes, as I explained, because it's sitting at the bottom of the HTTP stack, it can't render the web page absolutely, but it will give us a good idea of what the web page should have looked like. So we can at least tell if we're on the right request, if nothing else. As I said, this is essentially because this web browser that we're actually looking at just here cannot operate on the actual whole of the HTTP stack. It can only operate at the bottom there. So it will not render exactly. Okay, here we can see the request, so we can see the headers broken down into each individual header. We can see what the cookies were. Remember that the cookies will be handled individually. And we can also see what query string and form string parameters were. We can see the response headers and the HTML response body. We can also view this in a HTML editor, which for those of you who are used to editing HTML, this will make it an awful lot easier to read. And also, here's the context, so we can see what the context strings are. So we can see that all of these ones with a dollar next to them have actually been added by Visual Studio or by the controller and agent. So we can see the agent ID, we can see what the name of the agent was. And we can see how much weight was applied to him, for instance. If we scroll down to the bottom. Normally, we would have additional ones at the bottom, which would be all the ones that have been pulled out dynamically. So any actual one that was pulled out dynamically would be basically come up at the bottom of here. Moving on, and then we've got the details. So here we can see the two automatic validation rules that are automatically added in whenever you generate a web performance test. So we can see the response URL and the response time goal. Also, you'd get extraction rules listed here. However, they wouldn't, if they're not marked as required, they won't cause the test to actually fail. Okay, moving on. So let's have a look at some review questions. What things are captured recording a web test, and what is not captured? Well, the things that are captured are the HTTP request and any dependent requests which are passed out of that HTTP request. Things that are not captured are those actual dependent requests, as in the actual item, the object that's downloaded. Also, we don't capture things like JavaScript. We don't render images. Why would you use comments during recording? Well, if you don't use comments, what you'll actually end up with is a fairly illegible list of URLs, which will be extremely difficult to read. So if you put comments in, it just makes it that much easier to read. What things are collected and specified at the end of recording? Dynamic parameters are usually identified at the end of recording. It's essentially what it does is it plays back the actual web performance test, and it identifies any parameters that it can actually pull out of a previous actual request, and we'll put an extraction rule on that request. Hopefully we'll get a chance to discuss extraction rules in more detail later. What are the effective options that can be changed after playing a web test? Actually, I didn't get into demonstrating this, but I believe I'm demonstrating it. I'll demonstrate it again later, but essentially the options that we can change the number of iterations, we can change whether we're actually using think times or not, we can change the default path that cookies are actually stored on, and we can change what browser we're actually emulating. So, editing a web performance test. There are a number of options for actually editing a web performance test. We've already actually looked at adding a recording, which will simply add a recording at the end of a web performance test. We've also looked at the run options. Also, what we've got is adding a data source, so we can add any data source which is currently supported by Visual Studio. So this could be SQL, this could be CSV, it could be XML. It depends how complicated you want to get with your data source, how knowledgeable you are about dealing with these data sources. We can also set credentials. Now, what that is referring to is some websites require you to actually have either Windows or Linux-based credentials in order to actually utilize the website. So it doesn't actually give you a HTML login page. It comes up with a Windows login page, a Windows login window. Now, what you have to do to actually get around this is if you set credentials, you can set what user ID and password you're actually going to log in on. And you can actually bind these to data from a data source, as we discussed a moment ago. So you can actually have variable users. There's also what we call adding in a web test plugin. Now, what this is essentially enabling you to override the actual main class of the web performance test so that you can put your own C# or VB code into a web performance test. We won't be covering that today. That is an extremely advanced option, so we will definitely not be covering that today. Also, we won't be covering the next option, which is to add in a web request plugin, which is a similar proposition, but you would be overriding the actual individual web requests. You can also override things like extraction rules, validation rules, so you can get in and override just about anything. It's pretty much one of the standard things with Visual Studio. You can actually get in and override just about any element you actually want. What we also have is this option to generate code. Now, what this does is this turns your web performance test that you've recorded, and it just turns it purely into source code, dependent on which kind of test you actually initially set up. So if you set your test project up as a C# test project, it will generate it in C#. If you set it up as a Visual Basic test project, it will generate it in Visual Basic code. But it will basically give you a source code equivalent of the web performance test. One very useful option, which I don't know a single person who actually works with web performance tests who doesn't use this on just about every single web performance test he uses, is parameterizing your web servers. What parameterizing your web servers enables you to do is to actually identify every single web server that you're actually talking to. and take that web server and actually turn that into a context parameter. So what it will do is it will give you the facility to actually just override one variable in order to redirect the test from your test servers to your production servers that you actually want to test upon, rather than having to go through and basically re-enter every single URL, changing the URL section into where you're actually targeting your test. Also, in load tests, we have the facility of actually overriding a context parameter. So if you have a constant context parameter, which is going to be your server under test, and you've got 16 different web performance tests, you can just if you've got this single parameter that's constant across all 16 web performance tests, you only need to override it once in the load test, and that will target the new server. So it's a very good way of actually being able to be very careful about where you're actually targeting your tests. You can also use the promote dynamic parameters option. This essentially we've already seen, because it automatically runs this as soon as you actually run a web performance test. However, you may make changes to your web performance test, which it may well then go and decide that, right, okay, you managed to extract this particular parameter. Oh, I've recognized what you've extracted there. I can see it's actually this constant parameter over here. Will give you the opportunity of actually just replacing and adding in more dynamic parameters automatically. Set request details basically gives you some of the more commonly edited properties of requests in a web performance test in a tabular format, so that you can just edit them like you would a spreadsheet. So obviously, like I said, with add recordings, it allows us to add an additional section onto our web performance test at the end if you use a toolbar. You can also insert them into the middle of a web performance test by right-clicking and going Insert a Web Performance Test. Sorry, insert a recording, and it will allow you to actually record into the middle of a web performance test. And basically, it just allows you to complete the web test if you haven't already completed your whole recording, or to add new steps. Say if there's an additional step that has to be added in the middle that you couldn't record earlier. And the basic thing to remember is the web test recorder does actually live. It's an add-in for Internet Explorer. Later versions of Internet Explorer will very friendlily give you the option of going, right, would you like to disable any very slow add-ins? And when you go yes, that's one of the ones that generally will get disabled. So if you go in and it doesn't actually come up, the thing to remember is go into your add-ins and re-enable it. It won't work with every single version of Internet Explorer. Basically, any version from version 8 should be supported. Version 7, if you have Visual Studio 2010, if you have Visual Studio 2010 installed, it should have a web test recorder for Internet Explorer version 7 automatically installed. Generate code, as I said, will allow you to actually generate your web performance test into source code. This can be very useful if you're actually if you need to actually code directly around some of your requests. It's also very useful if you need to get in and you need to be changing certificates halfway through a web performance test without it causing problems or pop-up windows or things like that. Essentially, it's there so that you can get in and you can be very, very complex with what you're actually doing. You can also do things like I said of overriding extraction rules, validation rules, overriding your actual request, which is normally the preferable way to actually get in and get down and dirty with the actual code. However, you do have this option. It's slightly less tidy of actually working with a web performance with a coded web performance test. Essentially, the format is it will create a new custom request for the URL. It will then do things like it will add in additional items such as query strings, form post parameters, extraction and validation rules if it needs them, and then it will essentially run the actual request, which it does with this command yield return the actual custom request. You can actually, once it's actually done that, you can get in and you can get into all the information, so you can programmatically parse things like the HTML body, the HTML request. You can get in and get into an awful lot of details at that level. So, editing a web test. So you can see it's basically presented in a tree structure. We've already gone over the run options and the add recording. As I said, there's also a facility if I right-click. Oh, sorry, hang on. If I right-click, I can insert a recording, which will insert it at that specific point. So basically, it will insert it after that request. And moving on. Next up, we should be adding a data source. The data source is supported, any kind of data source that's currently supported by Visual Studio. Moving on, we've got adding credentials, so we can actually set the credentials, so we could set my user ID and password for the Windows machine that we were actually logging into, or the domain of that particular machine that machine was residing on. We can also assign these to a data source, which we'll come on to. Actually, we won't be covering that on today's stuff. Adding a web test plugin, as I said, this is a matter of overriding the actual web performance test itself and actually adding our own code in at a very basic level. We won't be covering this today. Moving on, we've also got another one which we won't be covering today, which is adding a request plugin, which will enable us to override an individual request and add in our own code. We've also got the option to generate code, which we should see in a little bit more detail here. I'm just going to go with the default file name. And as we can see, it's just generated some C# code. And as we can see here, we've got the request. We can see that it's also adding in the comments, which will be played back. And we've also got the think time that it's setting in this instance. So it's basically, it's giving us all the properties that it actually sets for the actual specific request, including query string parameters. And essentially, it will run it with the yield return and then the specific custom request. And that was generating code. Moving on, parameterizing web servers. Essentially, as I said, what this allows us to do is this allows us to take the http://www.tailspintoys.com or whatever our base URL is, and it will identify all the different ones if there are a number of different base URLs that we're actually talking to. And essentially, it will allow us to turn these into context parameters, which we can then override at the load test level or at the command prompt level at a later stage. So if we're actually running this test as part of a build, we can do it there. So here I'm specifying what my context parameter name will be. If I click OK, we can see I've now got this additional branch in the tree structure, which is called context parameters, and it's got my TS equals my context parameter, what I want my context parameter to equal, which is, in this instance, the actual URL. And if we see here, we've got a double curly bracket, the context parameter name, and a closing double curly bracket. What that means is whenever you see these double curly brackets, they're essentially just saying, insert the context parameter I'm naming instead of this text. We've also got the detect dynamic parameters option. We will try to identify any additional dynamic parameters that haven't already been identified. I don't think it will find anything in this instance. It did not detect any dynamic parameters. And we've got the set request details option, which essentially lets us set the request, the reporting name, which we'll be covering a little bit later, think times again, which I'll be covering a little bit later, and the response time goal in a tabular format, just to basically make it much easier to actually change those particular properties rather than having to right click on the actual request and go onto its properties. So, creating an accurate simulation. Essentially, one of the problems with trying to accurately simulate a human interfacing with an actual web page is not everyone actually reads things at the same rate. Not everyone actually thinks at the same rate. Not everyone's actually as confident about which links they should actually be clicking on. Not everyone navigates the same page at the same rate. So what we've got in web performance tests is we've got what we call think times. Now, think times enable us to actually set an amount of time that we think the average person is actually going to take on this page before they click on the next request, or before they actually click on this particular request. Essentially, they're recorded when we actually record our web performance test. So when we actually do our recording, it will say, right, okay, he took 9 seconds over that one, so I'll record 9 seconds on that one, which is one of the important reasons why when I was adding comments, it was automatically pausing the web performance test so that it didn't actually have I'm adding a comment as the actual amount of time that it was actually going to take me to actually go on to the next bit of the test. They can be used optionally, so you can turn them off. Also, when we actually get to load testing, what we have is a facility we can either just use the static think times as they are, or we can vary them. We can specify that we actually want to use the think times that are there, but we want to put the default is a 20% variance, so it's plus or minus 20%, a random figure, which is up to 20%. Sorry, I should correct myself there. Editing think times, essentially after recording, you can go in and you can just right click on a particular request and basically just go in and edit the think times. You can also edit them in the set request details option that I demonstrated a few moments ago. Bear in mind they're expressed in seconds. So, think times. So if I just go over here, so essentially if I right click on one of these requests and go properties, I can see we've got a number of properties over here, and there's our think time properties. I can set that to the number of seconds that I think, and I'm going to specify 7 in this instance, because 7 is usually a good reference for how long it takes someone to actually go, right, okay, I've decided which link I'm going to click on. And if I go on to another one, and you can see here again, this one is 7 as well. If I go on to the very first one and bring up its properties, I can see that this one, it took 10 seconds. I think I was probably waxing lyrical about the web test recorder on that one. So, as we can see with playback, again, it's gone through it really quickly. So it actually defaults to not using think times when we're actually testing a web performance test. But what we can do is we've got a couple of additional options. So we can run the test again, or we can go and edit the test settings for this particular session. So when we close this web test result, we will essentially lose the changes that we make to the settings, but we can change the number of iterations that we're going to run. We can also specify one per data row. We can specify what actual browser we're going to simulate. We can specify think times. And then we can just simply go in and run the test again. And we can see now it's thinking and it's counting down until it gets to the end of its think time before it moves on to the next test. And this is basically just so that we step it through as an actual end user is likely to be the kind of rate that we expect an end user to actually be performing using a web page. So here we can see we're now on iteration 2, so we changed the number of iterations. We can also see that if we look up on the actual test in progress bar, we can see that we're currently running it across a LAN. So our test settings, which you heard about earlier, specified that we're currently specified that we're running it as a LAN, but we've overridden it and we've said we're doing it as Firefox 3. So I close that. Now, moving on, dynamic parameters. Now, we've discussed dynamic parameters a little bit. Essentially, what dynamic parameters are, they can be all kinds of things. They can be specific to the actual server, the physical machine that we're actually talking to, which means that if all of a sudden, when we actually come to do our load test, we've got a tolerance of on our load sharing software, our load distribution software, on our actual production environment, our load balancer, that's the word I was looking for. If we've actually got a threshold of about 50 set up on that, so once we hit 50, we actually want to go, right, okay, you've got to spawn another server and get it up and running. If we don't actually identify these dynamic parameters, and there are some server-specific ones, when we actually come to actually run the actual the actual web performance test in a load test, and we've got 100 virtual users, if we're firing requests off to the actual server, and it's going to a different server, but it's still saying, still giving values that are pertinent to the first server, that server is going to fire back a load of errors at us, and the actual test is going to fall over. So what we actually need to do is we need to identify our dynamic parameters and actually extract the values that we actually need to be pulling off of the various responses we're getting and add them in to the query strings that we're actually sending back to the servers. So that when we actually come, it doesn't have to be a server-specific thing. It could be a database-specific thing. If the database has changed since you wrote your test, the options that you're actually specifying as hard-coded may no longer be valid. So it's very important that you actually try and get valid information that you can then pass back. Now, most dynamic parameters, the most common dynamic parameters, certainly the ones that it does automatically pretty much every time, are the set hidden fields. So any hidden fields it identifies in a HTML web page, it will automatically do at runtime. And if it detected them during recording, it will automatically have them set in the actual request where they need to be a query string. One good example of a hidden field is the view state in ASP.NET, which is always done as a hidden field, but web developers use hidden fields quite a bit for actually passing parameters around. So you quite often find that on this form there may only be 3 form parameters that you can actually see, but there might actually be 6 additional hidden fields, which are all bits of information that the web developer is actually passing from a previous request to this request, or wants to pass from this request to the next request. Anything that's set in cookies is handled automatically. So basically, cookies are handled exactly the same way they're normally handled by the browser. So if it comes in the header as a set cookie, it will set the cookie value, and then that will be passed on when it does the next request. and it will just be passed backwards and forwards and incrementally updated. Query strings and form post parameters. Of the two, form post parameters, you're more likely to actually see being automatically detected, but although you may need to actually do them manually yourself at some point. Query string parameters, it will get them sometimes, it will not always get them. So these are the ones you're more likely going to have to do by hand at some stage. And basically, like I said, hidden fields are detected at runtime. Cookies are all handled at runtime, and query string and form post parameters are basically detected at the end of recording a test or when you click the detect dynamic parameters button. The one difference I would say is at runtime, hidden fields are detected. They're also detected if during the actual recording phase and put in on the query strings when it's actually at the end of the recording phase. So if there's a new hidden field, it might well be coming out here, but if it needs to go on a query string, it won't be happening unless it was actually there when the test was actually recorded. So dynamic parameters. So here we can see our web performance test. And I'm going to add some additional steps. Now, first thing I'm going to do is I'm going to pause it because I've already got the first 3 steps that I actually wanted. So I'm going to click on Tailspin Toys, I'm going to click on Model Aeroplanes, and I'm going to click on Photocopy Flyer. And that puts us basically where we were when we ended the recording the first time around. So I'll now press the record button. I'll add in the comment for what I'm about to do, which is add to cart. I'm going to click OK. Click add to cart. Add another comment. In this instance, I'm going to specify checkout because I simply want to actually go to the checkout. I'll click on the checkout. As you can see, it's automatically filled in the form for me because I've done this on this particular virtual machine before. Add another comment. And I'm going to specify review order because the next thing I'm going to do is I'm going to click on review order. Okay, so here we can see it's come up with the review page, and I'm going to basically stop it there and go, right, we're going to detect the dynamic parameters. It should actually come up with some this time. Yes, here we go, and it's picked up all of the dynamic parameters associated with that form. So all the form fields, it's seeing what we've entered into them, and that's what it's going to default to. So if we actually go into our web performance test, we can actually see our extraction rule there is pulling out the actual form fields that are coming back as the response, and then we can see they're being set for when we actually click on review order. So those values are actually being passed, and we also had a hidden field there. So when could you edit think times? Essentially, after we finish the recording, editing think times we can do in 2 places. We can either go into the properties of an individual request and do it there, or we can do it in the set request details, which gives us all the requests in a tabular form. Just one thing to remember when you're setting think times is they're expressed in seconds, and what you're actually representing is how much time you actually think somebody's going to spend on this page before they move on. It's only there as a method of pacing the actual web performance test to simulate an actual a human at the actual end of it. What is the principal purpose of setting credentials on a web test? Essentially, if the web test requires Windows or Linux-based authentication, as in, it's unlike most web pages you come across, they have a specific page for logging in, which is just another web page. In this instance, it would come up with an actual login window or an actual login form under Internet Explorer. Essentially, it's just a matter of getting around that. You can actually specify what the Windows user ID and password of the user will actually be, or what the actual user ID of on the Linux box or on the domain. The only Linux one that's supported is Kerberos, as far as I'm aware. Why do we set think times? We set think times like I think I've already covered this sufficiently, but just to reiterate, we set think times in order to simulate an actual end user's pace. So, understanding load tests. So, the basic principles of load testing are essentially what we're trying to do is we're trying to take a system and we're trying to simulate it under the load of multiple users. So it's like we might, if it's an in-house system and we're only going to have a very light load using it, we might only try and take it up to 20 users. But what we might also do is, okay, what we're actually writing is the ticketing system for the 2012 Olympics, in which case we actually want to be able to cope with about 200,000 users at a time. Guess what London 2012 didn't do from what I've seen? They didn't load test properly. Essentially, most load tests are performed over time. It depends what kind of load tests you're performing. Particularly things like stability testing, we would perform over a very, very extended period of time. So we'd run the system at pretty much its anticipated load, but we'd run it for maybe a week. The idea there being essentially to actually try and pick up on anything that's ongoing that's actually going to cause us a problem. So are we starting to run short of memory on the production servers that we're testing on? Are we starting to run out of disk space? Are we running into any other problem that seems to be incremental and just building up over time? Essentially, that's the whole purpose of doing stability testing, is just to see, are we going to run into problems? If we run the server for more than a week, are we going to have to reset it once a week because it's running out of memory every time? Essentially, the main building block of a load test is normally a web performance test, as I've just demonstrated how you actually build them. I may be going back to web performance testing a little bit later in order to cover validation rules and extraction rules. I haven't covered them yet because I think that I'm going to run out of time before I can, but if I don't run out of time, what I will do is I will head back and I will just quickly cover them and explain them. Essentially, aside from web performance tests, there's another two kinds of tests we can actually do. So we can do a unit test, which enables us to actually test an actual API under load, for instance. So we could do client-server stuff using the unit test to actually go, right, okay, well, I've got this scenario, which I'm doing in this unit test. I've got this scenario that I'm doing in this unit test, which is basically simulating what an end user might actually be doing from an actual client-server. Select this server for where this equals this. It could be doing a SQL, it could be doing all sorts of things, really. It depends on what your actual back-end database is or what APIs you actually want to call, because you can load test your APIs as well. Often, if you're going to be working on simulating more than 200 users, you really need to be working on a test rig. In fact, Visual Studio won't actually allow you to test from Visual Studio itself on its own with more than 200 users, 200 virtual users. A test rig basically consists of a controller and multiple agents, and each agent is capable of running an unlimited number of performance tests, unit tests, although each agent can really only run one coded UI test. The basic caveat on that is because the coded UI tests, as we saw earlier, are actually interfering with the user interface. If you try and run two at the same time, basically what happens is they basically interfere with each other, much the same as Adrian was explaining about, I've got to put my hands in my pockets here because if I interfere with the keyboard or mouse, I'm going to actually break the test. Another vitally important thing to remember when you're doing load testing is the danger of accidentally doing a distributed denial of service attack. Essentially, I've seen this happen so many times. You try to be so careful. The last time it happened, it was a case, to me, it was a case of this website that I was actually testing the test version of. One of the web services that the actual website was actually calling behind the scenes was actually calling the actual live web services. So I'm calling the system under test, and it's actually calling a live system. Unfortunately, there was very little we could do about that at the time. It essentially just took down the actual the web services, essentially, because we were doing stress testing. Also, what I've seen, another common occurrence is if the domain is improperly configured. I have certainly seen it on a number of occasions where, because the domain hadn't actually been quite properly configured, we actually managed to take out the call center in this building because all of the load that we were actually generating, that we thought we were just generating on our little bit, was actually going through the call center. So when we were actually doing our test, we were actually basically, we ended up shutting down their call center temporarily. It wasn't for long, because essentially once we knew, we stopped the test, and they were almost straight back up and running. It is very, very dangerous, so you have to be oh so careful. So before you actually think about running your load testing, you need to make sure that on the back end, the guys who have actually set up the test environment have actually made sure that you're actually all the web services you're talking to, all the client server stuff that you're talking to is actually on the test environment, and you're not talking to anything that's live, and also that the domain that you're actually working under has been configured correctly. And normally what I do, if I'm on site, what I try and do is I will get some of the spare testing capacity, as in some of the other testers, just as I'm about to actually run my test, just to quickly run around the building and warn everyone, and if there is a sudden fall off, we'll stop the test and we'll see if we can figure out what actually went wrong. So what we'll generally tend to find is if people are warned, you'll quickly start getting phone calls. Of course, you'll also start getting phone calls because somebody's Microsoft Word isn't actually running at the appropriate speed. Unfortunately, that just happens. So understanding load tests. Moving on. So now we're going to look at creating a load test. Now, there are a number of tools involved in load testing. What we have is when we actually create a load test, we've got a load test wizard. This wizard basically takes us through the whole process of all the parameters we actually need to set up when we're actually creating a load test, so which tests we're actually going to be running, which browsers we're going to be emulating, what proportion we're actually going to be doing the tests, or the browsers, so it enables us to set up that. We've also got a load test editor, which I'm not going to go into great detail on today, although if we have time later, I may go into some detail on it. What we also have is a SQL-based results repository, which is based in Microsoft SQL. One of the issues you often run into with this is, or if I'm using someone else's test rig in order to actually do my testing, what I often run into is they've actually only got SQL Express at the back end, which means that if you're on SQL Express 2008 or before, you're pretty much limited to 4 gigabytes of database per database. One of the things with these load test results is they do get quite big, particularly if you've got a lot of data coming back. So if you're doing a very, very granular test, so I'll be talking more about how we can actually reduce the size of these results repositories, or reduce the amount of data that's actually being stored in them a bit later. But it's one to keep your eye on. Possibly you actually want to go and actually start looking at archiving stuff out of your load test repository and then just bringing it back in when you need it. The other issue you're likely to run into with that is if you haven't actually got much space on the hard disk. Of course, if you're using SQL Server 2012 or above, well, sorry, there isn't an above at the moment, but there will be in a few years. Essentially, you've got 8 gigabytes of space, so they've actually doubled the capacity. Also, what you've got, another tool that we've got, is we've got the load test monitor, which basically allows us to actually view a load test and see some of the reporting information that we'll get at the end, but only very much in a snapshot of what's actually going on with the test at the moment. So we can make a judgment call about whether to abandon the test because we think there's a problem with the web performance test, or there's problems with the actual configuration of the production environment that we're testing on, or we've actually got up to the level that we're actually want to be at, but we're encountering problems that we think we can configure out and then run the test again. So there are a number of reasons why we'd want to actually be monitoring the test. This is one of the reasons, along with the direct distributed denial of service issue that I was relaying on a former slide, is one of the reasons why I say I would never actually automate running an actual load test. I would always want to be there whilst it's running. The only exceptions I'd say to that is if you are using Lab Manager, you do have the facility to actually run your load test under network isolation. So your controller, your agents, and your production environment are all running on a private network that's been completely isolated from everything else on your network, which is one way of doing it. The downside with that is they would all have to be on the same virtual machine, the same Hyper-V host. And if you're familiar with virtualization, you'll know that if you're actually going to be sharing processor cores across different machines in this environment, essentially you're not actually going to get a realistic view of what the load is, because essentially the same machine really is, or the same resources are actually going to be generating load as well as coping with it. So you're actually going to be coloring the results because your controller and agents are actually on the same machine that's being tested. So creating a load test results repository, essentially there's a SQL script that's available. So if you go into Program Files, Microsoft Visual Studio 11, Common Salmon folder, IDE, and then you'll find that there's a load test results repository. Essentially all you need to do is run that from your actual SQL Server interface, which will enable you to actually just execute that script. In this instance, we don't need to, because it's already been generated. One caveat I will say, if you're actually looking at the SQL, is although everything else seems to have been updated for 2012, it's still calling the database load test in 2010. Load test results 2010 will be the name of the database. So it's still pointing at the old name. I don't know if they're going to update that anytime soon. I would imagine so. Essentially, we can basically configure which actual database, which SQL server we're actually going to be pointing at for that. So we can come on to that. Like I said, it's stored in SQL Server. You can call your results from your local machine, from a test controller, or from an actual specific machine that's just a SQL server. And like I said, they're created by a script which you can locate just here. So running the new load test wizard, essentially I would go onto my project, I would right click, I would go add, and I would specify a load test. which would then give us the load test wizard. The load test wizard will essentially come up with this welcome screen to start off with, and will then take us through a number of different options that we need to actually go through for setting up our scenario, setting up our load pattern, what test mix model we're actually going to use, what test mix we're going to use, are we going to simulate running at different speeds of network, which can be important if you're trying to isolate bottlenecks. So settings for load tests. Like I said, the initial scenario, bear in mind we can have as many scenarios as we like. We'll have its own individual load pattern, which could be a constant load, so we'll be specifying, start with 20 users, continue with 20 users, and finish with 20 users. We can have a stepped load pattern, which would give us, we could start with 1 user, and every 10 seconds we could increment by 10 users until we reach a certain number of users. Also, we can do what we call I've forgotten what it is. It's targeting a specific metric. I've forgotten what the name of it is just at the moment. It's targeting a specific metric. So we can specify if it falls between these two, then if it goes above this one, then start decrementing it. If it goes below this one, start incrementing the number of users, just so that we get a number of ideas. So we can say, right, so that's a goal-based. It's a goal-based load pattern. So what we're basically saying is we could specify, right, how many users can we actually load, get an idea of how many users we can actually load and run at an average an average page speed of 8 seconds. So that's the average time it takes for each page to actually respond is 8 seconds. So we could actually specify the higher window range of 9 seconds and the lower one of 7 seconds. And if it falls below the lower one, start incrementing the number of users. If it goes above the higher one, start decrementing them. And it just gives us a facility to actually get an idea of how many users we're actually running at, to have a specific metric running at a certain level. We can also specify our browser mix. Now, our browser mix basically allows us to actually specify, we're going to say 10% are running this version of Firefox, 10% are running this version of Firefox, 20% are running this version of Chrome, another 10% are running this version of Chrome. We've got 10% running this version of IE, 10% running this version of IE, and 10% running this version of IE. It just allows us to actually specify exactly what proportions we're actually going to be running different browsers in. Bear in mind that servers won't necessarily respond the same to two different browsers. So some differences may actually occur on the actual server depending on what browser you're actually communicating as. And also, different browsers open a different number of actual sessions to the actual server when they're actually connecting to it. So there's one kind of browser might open 5 virtual sessions in order to actually get all of its dependent requests. Another one might actually open 10. So that can vary quite a bit as well. So we can also do the network mix. Bear in mind you need a special driver in order to do the network mix. So the network mix, essentially, when I demonstrate this later, I'm going to keep it on just the LAN option. Essentially, this is because if you're trying to actually copy me when you're watching the recording of this, or at a later stage, if you haven't got this driver, it won't let you actually go forward, and it can confuse some new users. We can also specify what our test mix is. So we've got test number 1, we're going to run at 50%. Tests number 2 and 3, we're going to run at 25% each. And we've got our test mix model, which enables us to actually specify how we're actually going to actually take these mixes and apply them. So are we going to base that on the total number of tests that have been performed so far? So we're going to apply each of these mixes based on the actual total number of tests that have been done so far. So if we're falling short of one of our test mixes or one of our network mixes, it will try and do that one next time. Are we going to base it on the current users that are actually running? So we're constantly running with our relevant mixes always as close to accurate as possible. Are we going to base it on user pace, or are we going to base it on just sequential tests? So basically, it will just say, just run the test sequentially. Moving on, we've also got computers and counter sets. Now, what computers and counter sets enable us to do, if you recall earlier on, I believe both Peter and Adrian mentioned these things to do with test settings called roles. But if you've got a SQL server, you can specify the name of the SQL server machine and specify that you want the SQL server counters, so that will get all the perfmon counters off that machine to do with SQL server. If you have an IIS machine or an ASP.NET machine, you put in the name of that machine, and you'll get all and specify that you want all the counters for that particular type. You can pretty much get any perfmon counters that are available, including bespoke ones. Essentially, once we move on from computers and counters, before we move on from that, some counters will be done automatically. So stuff specific to, the counters specific to what we would normally expect from a load test will be done automatically. And also anything to do with our controller and agents, or if we're running from our local Visual Studio machine, from our Visual Studio machine, so how much memory is available, for, what levels of processor running at, is the hard disk running fast enough, things like that. They will all be done, they will all be downloaded and stored. What we can also set is our initial run settings. So what our initial run settings basically allow us to specify is what kind of storage we're going to actually be running. So we can specify whether we're actually going to store our results or not. So we could actually just take the runtime snapshot and just take that for our load test results, in which case it won't go into the SQL repository at all. We can also specify the level of timing information, whether we want the full timing information, whether we want just statistical timing information, or whether we don't want the timing information at all. We can also specify whether we're actually going to be downloading specific test logs and how many and what proportion of test logs we're actually going to download. We can specify the duration of the test, and within the actual wizards we can specify the warm-up period. We can't specify the cool-down period within the actual wizard, although we can get in on the properties and specify that. And we can specify other miscellaneous ones, so we can specify the maximum number of sessions any particular virtual user can actually open for downloading results. So we can actually reduce that to, say, 5 sessions, but bear in mind that will impact on your browser mix, because your browser mix, if you reduce that, your browser mix won't necessarily be reflecting exactly how the browser would interact with the actual server. So, like I said, we've got various different load patterns that we can actually specify. So we can specify a constant load pattern, which just basically will bang along at the same rate all the way along. So you can actually use this for a certain amount of simple spike testing. So you can just have a very short duration test that goes in at 500 users, just to basically get some idea of how the system copes with 500 users all try and log in at the same time. 500 users logging in at the same time, bearing in mind that logging in, because it's a very highly secure process, would normally be quite slow in itself. That is probably going to be the most likely thing that's going to make a system fall over at the spike testing stages anyway. So yes, you can use constant load testing for doing your spike tests. You can also use it for just getting benchmarks and things like that. Stepped load basically enables us to actually simulate what would normally happen. So what would normally happen when we're actually running our test is users would actually log in gradually. So some people will arrive for work early in the morning, some people will arrive for work later in the morning. So some people will actually be late, some people will be early, some people will be on time, but not everyone will log in at the same time. This is not necessarily all that relevant. It depends on what kind of testing you're actually trying to do. If you're trying to actually shake the system and see how much change it can suddenly cope with, constant load tests are going to be your friends on this one, because you can actually specify, you can figure out exactly how many people can actually log in at one time. And like I said, we've also got the facility of actually saying, well, based on this specific metric, if we want this specific metric, such as 8 pages a second, so we want the system to actually be rendering 8 pages a second to various different browsers. Downloading 8 pages or uploading 8 pages a second to various different browsers. We can see exactly how many users will actually be able to run and keep the system running at that metric. The test mix model, again, like I said, you've got a number of options, so we can specify it based on the total number of tests. Essentially what this is going to take is our subsequent mixes that we're specifying and apply them according to a different paradigm. So we can specify what paradigm we actually want to apply these in. So we can base it on the total number of tests. So from the very, very start of the test, if we specified in our test mix, for instance, that we want 50% of tests to be running test 1, and we're about to actually run a test, and we notice that the system notices that actually only 10% of the tests since we actually started have actually run the first test 1. It will run, that will basically say run test 1 until that gets up to 50%, or until there's a bigger discrepancy on one of the other percentages. Also, we can base it on the virtual number of virtual users. So like I said, this will basically, in real time, if we specified, like I specified earlier, we've got test 1 50%, test 2 25%, test 3 25%. Then if test 3 is only running at 20% of the current users that are currently running, then the system will try and throw in more test 3s until it hits around about 25%. Based on the user pace, we'll just basically base it based on how quickly the actual users are getting through it. And sequential, we just basically bang through and just do them in a sequential order, which can be useful. I find that one specifically very useful if I'm testing web services. So here we can see the test mix. So you can see I've got 4 tests on this particular slide, and I've just specified that each one is going to be run 25% of the time. I could specify that one of them is going to be 50%, and the rest of them are going to be equally divided amongst the remaining percentage, so the remaining 50%. So some of them will be slightly more than others because you can't equally divide that by an integer. But as you can see, we've got the sliders, so what we can do is we can slide these across. When we do that, it will actually lock that one in place, so that when we use another slider, it's only affecting ones that haven't been locked. And also we can specify, so if we highlight one and we can add, remove, and we can just specify distribute. All distribute will do is we'll just basically revert them all to being equally distributed, which it will try to do as close as possible, but you might get 1 or 2 that are just 1 out, simply because you can't distribute equally with integers sometimes. The network mix model, the network mix, again, as we can see, we've got 3 specifiers. So we're specifying LAN, specifying 3G, and we're 1.5 megabits per second cable DSL. And we're trying to do it fairly equally, looking at it, because of the integer issue. One of our LAN is running at 34%, and the other 2 are running at 33%. But again, this will be affected by the actual test mix model. So when we actually come to actually run our tests, if one of these is deficient, it will try and run it as that particular kind of network. We've also got our browser mix, which again, we've got a similar scenario with the actual mixture, but we can specify whichever browsers we like. Pretty much all the modern browsers are listed here. You can go back to some very old ones. You can't quite go back as far as Mosaic, but you can get fairly close to it. Basically, it's, like I said, it's just giving us the opportunity of actually, what we can do is we can go onto the internet and we can download from an analytics site, we can download actually what percentage of web browsers, of web users are using this particular browser, what percentage are using, so we can actually see a breakdown of the top 20 browsers, and we can try and emulate that. The only problem I've got with that is I've never found two of these analytics sites that agree with anything less than a 25% tolerance. So it's not actually all that good at that rate, but it will give you the facility to actually simulate something that someone else is reporting. So you can, if you take a reasonably reliable one, and you can actually specify that when you're actually reporting, you can say you've got your browser mix from this particular site. Counter sets, again, we can specify exactly based on which computer we're actually running on. So we tell it the name of the computer, or we can give it the IP address, and we can specify which counters we actually want to get. So we can get the ASP.NET counters. In this instance, we're going ASP.NET, IIS, and SQL Server. So my guess with that would be that that's not actually what we're actually demonstrating, or what that slide is actually demonstrating is not actually a production environment, because normally I would find that the ASP.NET, IIS, and SQL on a production environment, if you're going to have a lot of end users, will probably be on separate servers anyway. But essentially, we can specify as many machines as we like, and we can get whatever counters we want from them, as long as they're Perf1 counters. We can get bespoke counters. So if your program is actually creating its own specific counters, we can pick them up and we can include them in your reporting. Actually, just stepping back, I was mentioned earlier about how when we're actually running our load test, one of the things that can cause us problems is if the load test results repository runs out of space. Well, one of the issues that can affect that and affect how much space is actually being taken up is based on the number of counters that we actually have. So what we can do is we can actually, at a later stage, we can actually go through and say, any counters we don't want, we can actually remove them. What we can also do with counters is we can add threshold violations and error levels. So we can say, well, actually, if the processor goes above 70%, I want to issue a warning that there's an issue going on here, and I actually want a warning that I can actually report upon. So I can specify that I've got so many threshold violations because of this particular warning. I've got so many because of this particular warning. So the system isn't actually running as we were hoping it would. And also, you can have a secondary level to that, which we refer to as, generally, it comes up as errors. And that you might say, well, if the processor goes above 95%, then yeah, we want to actually start saying there's a serious problem here, and again, we can report on that. And actually, one of the summary report actually does give you information based on that. But essentially, what we can do is we can reduce the amount of space by reducing the amount of actual counters we're actually collecting. Run settings. On the wizard, it will enable us to actually specify the warm-up period. Why we might use a warm-up period is if we are actually spawning some of our servers that are under test, our production environment that we're testing is running under Lab Manager, and it's actually being spawned as we actually run our tests. Then what we might actually want to do is we might actually want to put a warm-up period on our actual load test, and what this warm-up period will actually enable us to do is essentially it just gives the production environment time to actually breathe and time for the machines to actually boot up and stop populating system trays and things like that if they actually have to log in, and basically starting roles and starting services and things like that, things that generally take time when the machine first starts booting. So that's why you might have a warm-up period. If the machine under test is actually a static machine that's actually already up and running, then you probably won't bother with an actual warm-up period. You can specify how long you're going to actually run your test for. Bearing in mind, if you're using a step load pattern, you need to actually calculate how long it's going to take to actually reach the pinnacle of its step, and then how long you actually want to run that for. And basically have that as the sum of that as your actual duration. We can also specify that we actually just want to run a fixed number of iterations of a test. So we just want to run each test 100 times, 1,000 times. We can specify an actual iteration. What we can also specify is the sampling rate. Now, what the sampling rate specifies is how granular the actual data in the results repository is going to be. So the smaller that figure, the more granularity we're actually going to have. The bigger that figure, the less space we're going to take up with the results repository, because if we make that 10 seconds, the results repository is basically going to take up half the amount of space. But we're only going to have data for every 10 seconds. So that it will take a snapshot every 10 seconds and store it. If we have it at 5 seconds, in 2010, you could specify any figure you wanted in there. In 2012, they've actually specified that the minimum value is 5 seconds. If you actually want to get in and set it lower than that, I'm afraid you're going to go in on the actual XML of the actual load test. So actually load the load test in an XML editor and go in and change that setting. It's not that difficult to do once you know how, but it's not for the faint-hearted. What we can also do is we can give it a description. We can specify whether our web performance test logs are going to be saved if the test fails, which is often vital for if you're actually going to debug what's actually going wrong with an actual web performance test. You know, it can be vital for actually ascertaining if it's a problem at the actual server, if it's a problem with the actual web performance test. As one of the ones I'm sure you're all going to love if you get heavily into doing load testing is when somebody's actually changed the system under test and hasn't actually gone and told anyone about it. So you actually go to run your test that was running fine last week, come to run it this week, and all of a sudden the actual part that you're actually testing has actually changed. Of course, this is something you can do with, you can track with MTM, and you can see which bits are traced, as Peter was showing earlier. You can compare two builds and see exactly what's changed, so it does give you the facility to actually get into that. Also, we can specify what validation level we're actually going to run, because you can specify each validation rule will run at a specific level, so it's high, medium, and low. If you specify low, it basically just means that all the low-level tests will be done. So all the high-level tests will be done. If you specify medium, it specifies all the medium and high-level tests will be done. And if you specify high, it means that all the validation rules will actually be run. So that's basically, it's a way of filtering what validation rules you're actually going to run. So you can kind of have it as 3 tests rolled into one, if you like. So creating a load test. Okay, so first thing I'm going to do is I'm going to select my project. I'm going to right click, I'm going to go down to add. Sorry, get the right one. Add. And I'm going to add a load test. Oh, sorry, new item. I could do it as a new item, but I'm going to go load test in this instance. And as we can see, it comes up with this lovely welcome screen that everyone ignores. And then we can set up our scenario. So what I can do is I can give the scenario a name. And what we can also specify is whether we're going to use the recorded think times statically, whether we're going to use them based on a random distribution. So like I said, we can add a random up to 20% variance, either positive or negative. or we can specify not to use think times. It would be unusual not to use think times, but you might do it if you were doing things like stress testing. And we can also specify a think time in between web performance tests, which I would say would normally be quite vital if you're actually doing web service testing. So I'm just going to specify 5 at that point. I'm going to go on. Okay, and then I'm going to specify my load pattern. So the default is 25 constant. Essentially, we can specify any constant load we like. It's going to start with that number. It will continue with that number. So it will just be that number all the time, and then it will move on, and when it's done. Step load enables us to actually start at a specified number of users. We can, based on the step duration, we can increment a specified number of times until we actually reach our maximum number of users. I'm going to specify 50 at this point. We can specify a test mix model, which gives us 4 options. Essentially, we can space it on the total number of tests, which I believe I've already explained to a certain extent. We'll basically go back to what tests have we run so far, what proportions have they been running, do our actual tests, our network mix, our browser mix, have their proportions actually been run properly? So I can go in and I can add specific tests. So I'm basically taking my coded test and my main web test that I've developed, and I'm going to specify that it's running about 80% to 20%. So you'll notice that that one's been locked at 80%, and the other one, that's still available on a slider at 20%, but there's no other options at the moment, so that would basically not be doable. Moving on. We've got our network mix, so I'll just temporarily add a couple in here. So we can specify how we're actually going to divide our network mix model up. What I'll do, because you actually need a specific driver, I've actually got it on the environment that this was recorded on, but you do need to actually have it at your end, so I just want to avoid confusing you guys. And we can specify what our network mix is going to be. So what our browser mix is going to be. So we can specify that this browser is going to be slightly more than that browser. And like I said, we can download this information off the internet if we so wish. And as you can see, using the sliders, we can actually tune it any way we like. And as we use each of them, you'll notice that the little lock at the side of it just gets a little tick in it. And we can do it for all the different ones. Moving on. Counter sets, so we can actually add in a specific machine, so we'd give it the name of the machine. And then we can specify which counters we actually want to get. In this instance, it's going to cause us problems for our demonstration, so I'm actually going to remove it. But you'll notice that there are some that are automatically included by default, so our controller and agents specifically. Our run settings. Essentially, we can specify what our warm-up period is. Again, like I said, if you've got machines that are going to be spawning and booting at the start, you might want to give them a breather. I mean, I would demonstrate that for demonstration purposes by just specifying 30 seconds. And we can specify our actual duration. And we can specify whether we want to actually do test iterations, whether we want to do, so we're going to specify 3 minutes duration, and we can specify whether we're going to do test iterations. We can specify our sampling rate, so we can reduce the amount of space that the actual results repository is taking up. We can add a description. We're going to say whether we're going to get our web performance test logs, and what level of validation we're actually going to run. Click on Finish, and there's our web test. I'm going to skip over this section because I think I'm actually running a little bit behind. I've got about a quarter of an hour to 20 minutes left from what I can tell. So I'm not actually going to go into the different kinds of testing. And okay, so what I'm going to go on to now is basically running load tests. Now, in Visual Studio 2010, you could basically run load tests from 3 different places. You can also run them from the command line as well. However, I do not recommend that as a general rule because it encourages too many people to just schedule them to be run overnight or to be part of the build process for some awful reason. So we used to be able to run them from test view and from the test list editor. However, the test view and the test list editor have both been depreciated in the latest version of Visual Studio, so they're no longer there. So essentially we can just run it from the load test editor, or like I said, from the command prompt if we so wish. So let's actually go in and run a load test. So all I'm going to do is I'm just going to right click on my load test and I'm going to go run load test. There is an option upon the actual toolbar as well, which will enable me to actually run or debug my load test. I might debug it if I say overwrote any of the classes involved in the actual load test itself, or any of the classes involved in a particular web performance test and wanted to actually debug them. So I'm simply going to run the load test, and the first thing that should happen is it should actually give us a problem. Oh, no, sorry, it's not actually going to give us a problem. I'm sorry, I missed a step out there, and when I was recording this, I forgot to actually include the recording of the step. There is an additional bit which I will explain at the end. Essentially, what we've got our warm-up time period, which we're still looking at. We're getting our graphs coming through, so we can see our controller and agents, what the processor is running at, what the memory is actually running at. We can see what our key indicators are, what our response times are for various bits. So we can see our response times are actually starting to come through now. And that's basically running a web performance test, so a load test. Moving on. So what's the main purpose of a load test? Well, it's to simulate running a system under load. We can run it under more load than it normally takes, which would be a stress test. We can run it under less load if we so wish. We can run it for an extended period of time to give us the opportunity of basically testing to see if anything's actually going wrong over time. So we've got a memory leak which is causing the system to run out of memory, for instance, or we're not cleaning up all our temporary files, so the system is running out of disk space. What kind of testing might we do? The principal testing method would be web performance tests. We can also use unit tests, and what we can also do is coded UI tests. However, we are limited to one coded UI test per user interface we have available. So if we have a test agent, we can only run one coded UI test on it, and also that test agent would have to be specified that it was running as an interactive agent. So analyzing a running load test, well, the differences between a running load test and an actual load test that's completed, essentially we don't get all the information with a running load test. We don't get any detail, so we can't drill down into individual tests that easily. We don't get the summary report, which is produced at the end. Also, all the information we get is a snapshot of the information, so we don't get any of the timing details until the actual load test is finished. They're all uploaded from the agent at the end of the load test. So all the timing information, whether we're asking for full timing information, statistical, or just no timing information whatsoever. If there's no timing information, it won't get uploaded, obviously. But essentially, when we're actually running a test, we're just getting the very basic information. We've got enough that we can diagnose whether we might actually want to stop the test and do some reconfigurations, or stop the test and actually go back and have a look at some of our web performance tests, because we've noticed that, this web performance test keeps falling over. Why does it keep falling over? Well, it can't find this particular dynamic parameter, and that's because we've still got it set up as a constant, so it's causing an issue. So once we've actually come up with that and we've figured out what's wrong with that, we can come back and actually run it again. But it will give us information. It will tell us any errors that are being reported, any threshold violations that are being reported. But essentially, it wouldn't give us all the information, because not all the information is actually being passed to the load test repository as yet. And essentially, this information is actually just being held in memory on the computer that you're actually using to actually run your load test from. So if you're using a controller and agent, but the Visual Studio machine you're actually running it from, that's the machine which it will be in the memory of. So it only takes up a little bit of memory. Basic load test analyzer overview allows you to identify what errors you're running into. You can locate your bottlenecks. You can see how systems have improved. You can basically use it to analyze how your load test is progressing whilst you're actually monitoring it. So it can give you background into issues like, right, okay, do I need to stop the load test? Is something going wrong? Is the system, I'm looking at the counters I'm getting, are some of the systems that I'm actually running tests on, are they running low on memory? It could be a case of I need to allocate more memory to my test rig, for instance, or more cores to my test rig. Although that would not normally be an issue unless you've got the multiple virtual user license, which enables test agents to actually run on multiple cores rather than just using one core of a 4-core machine. Once the load test is actually finished, what you can actually see is the full details. Whilst it's actually running, you can only see the details that you're actually available at the time. But once it's completed, you can actually use it and compare it with other load tests. Basically, like I said, factors that will actually determine how big the results repository are the length of the load test, the sampling interval, remember I mentioned that one earlier, the number of computers involved in the test, because that affects the number of counters you're going to get. The number of counters again, any data collectors that you've got. So if you have specified in your actual test settings that you're going to use the ASP.NET proxy and get test impact analysis and IntelliTrace, I would expect your load test will probably start having problems at about 10 users, because those two bits of information can actually be quite large. So if you are getting those, my recommendation would be for load testing, turn off all your data aggregators. So all your data and diagnostics, turn them all off. Don't get any of them whilst you're actually running a test. What you might do is you might turn them on specific ones for if you are running into problems with an actual test. However, it will deposit large amounts of data in your repository should you actually be storing data from your data and diagnostics. Bear in mind, some IntelliTraces can actually get up into gigabytes if they're being run over a long period of time. And also, you can specify what your logging levels are. So you can specify how many error logs that you're going to get. So, yeah, if you've got so many failed tests, or you can specify you're going to get such a proportion of tests, of web performance test logs, whether the tests pass or fail or not. You can specify exactly what you're actually going to get, and that affects how big the load test repository is going to be. I know I'm banging on about this, but it's one of the things that people find themselves scratching their heads about, and it takes them ages to actually figure out. And given the fact that when you're doing load testing, you're usually doing it in a very narrow window of opportunity. The less time you actually waste actually trying to fix things, and the more time you can actually spend doing your actual load testing, the better. So again, like I say, when you're monitoring a running load test, you're basically looking at a snapshot of data. So you won't actually see all of the data. You'll only see you'll only see graphs for the data that you've got so far, and also this data will not be quite as fulsome and as accurate as when you've actually got the full details come back and when you're actually looking at the completed test, because you're not getting all the information, you're just getting enough information that you can make judgment calls on. Essentially, it's just going to be based on the most recent information that is actually given, and we quite often refer to it as an in-progress load test. So it's a load test monitor, in-progress load test, whichever you want to call it. I don't mind personally. Going back, let's actually have a look at an actual running load test. So analysing an actual running load test. So here we can see we've got our load test in progress. We've got a couple of minutes left to go. We can see we've got our counters. I'm going to get rid of that Test Explorer. Here we can see we've got our graphs, so we can see what our key indicators are. We can also drill down and actually see what they are on the actual key below. We can move on and we can see exactly how they're actually going to run. And also you can see that, yes, we're not getting all the data because we can only see the data for what we've actually seen so far. So as it progresses, what we will notice is the actual graphs will suddenly double in size in about 5 seconds. There we go. So we can see we've got that gap back, and we can see we're only looking at a certain amount of it. Moving on, we've got our page response times. So we can see if anything's actually spiking. One of the things I have noticed is quite often you get an early spike with these. It's normally down to the fact that I think some of the counters don't actually clear down in between running load tests. But we can, like I said, drill down. We can see here the number of the actual user loads, so we can see it's stepping up. And we can see we've been running at 50 users for quite some time now. And moving on. If we actually have a look at currently, we can see that the test is in progress. If we have any errors or threshold violations, they will come up here where I'm indicating. So they'll basically come up as links next to where it's saying test in progress at the moment. We can also remove different parts, so we can expand the graphs, or we can actually bring back the counters and the overview. We can specify the number of graphs, so we can just look at one graph at a time. And we can set it back to the default. And actually our test has just finished, so what we're actually now looking at is an actual completed test. And I will try and avoid the bits that I'll be coming on to later on. But what we can do is we can add a new graph if we so wish. We can specify whether we want to see the legend or not. So, and now that will be later on. So if we move on, and we can add analysis notes whilst the actual test is running. So I'm just going to basically say it's a demo run, and I'm going to put some analysis details in, so I'm just going to say it's completed, and click OK. I'm then going to close that, and that should be about that for analysing a running load test. How am I doing for time? I've got about 5 minutes. I will try and hurry along analysing a completed test. Essentially, with a completed test, when we actually go in to manage our results, we've got a controller, we've got load test. Actually, I'm going to ditch the slides and I'm just going to get straight into it, because it is actually the very last one. So I'm going to ditch the slides and just go straight on. And let's see, when we actually go in, if we right click and we go open and manage results, essentially we can specify which controller. We can see all the results we're actually running at the moment. This one's our latest one, which is the top one. We can see all the times I've run this test previously. Oh, sorry, I've taught this actual lesson on this environment previously without actually reverting it back to a snapshot. We can see what controllers we've got available, so we can get data from a specific controller. We can also specify a specific machine if it's just running as a standalone SQL machine for actually gathering our results. We can also specify what load test, so we can specify if a different load test has actually been run. So if we've got 4 or 5 different specific load tests that we've actually set up, we can specify a different one. Normally I'd specify a different name than load test 1. I'd specify something a little bit more meaningful. Also, as we look, we can see we can remove, we can export, we can import these results. So if we've exported one, we can import it, so we can move it from one results repository to another, and we can open one. As we can see, viewing a completed one, very, very similar to how we actually view an in-progress one, except we've got some more details up here. We've got a summary report. So we can specify, we've got a number of details, so we can specify the basic run details, so this will give us what actual, basically when it was started, how long it ran for, what the test settings were. We can also see overall results, so these will be average across the board statistics. So we didn't actually have any transactions, so I can't actually specify that one. But we can see how many requests failed. We can see, basically, we can see what the slowest 5 pages were. We can see what the slowest 5 tests were. We've only got 2 tests, but we can see the slowest one took 140 seconds. We can also see the full test results, so we can see the results for every test and for every page. And we can also see for transactions for the system under test, which there isn't anything at the moment. And we can also see for the controller and agents just below it. We can see that the average processor time was 5.03 seconds. The average memory available was 479 megabytes. And we can see exactly how many errors we got and what errors they were. There are no errors to actually report on at the moment, so we will just move on to the graphs. The graphs tab. Essentially, with the graphs, we can zoom and move these in. You'll notice these are all moving synchronously. This can be turned off or on. I'll show you how to do that in a moment. If I just move that, so we can specify that I've basically gone from 2 minutes to 2 minutes 20 seconds, and you'll notice it's synchronized all 4 graphs. It will not do this in the vertical. If I do this in the vertical, it won't. And I can turn off synchronizing it. So if I click there, that would turn that off. And if I now go and just slide that across, so I've just scrolled it, and I have to click on synchronize horizontally for it to actually synchronize the others again. If I just reset everything back to the full mode. And we can see here we've got our key here, so we can see what our average page times were, what our maximum were, what our minimums were. And we can see here on our graphs, we've got fairly good. Actually, it ran quite nicely, that test. I think that's the nicest I've ever seen that test actually run. But we've got keys for just about everything, and also what we can do is we can go in and we can change our plot options. So we can change the color, we can make it work at a different rate. So if I do that, I'm setting it to 1000. As you can see, we're getting much less representation on the plot of how many users. So if I set that back to 100, it should go about halfway up. And yes, it does. So again, we can change what the color is. We can also go in and play around with various counters. So these are all the counters that have been picked up during the actual run, and we can go and add them in to the actual reporting after the fact. So these have all been recorded. So if you have deleted them, you're not going to be able to use them. I can't drag that one, sorry. We'll expand it and then find the bit that I actually want and then grab the part that I actually want and then drag it, and that will show us that individual counter. Now what we can also do, here we're looking at tables. So we've got a number of tables that you can actually work with on a load test. There are errors, pages, you can get requests, transactions, SQL trace. We haven't got any threshold violations or any errors at the moment, so we can't actually show you those. We can see exactly how many pages, and we've got down to our 95% and all that, so we can actually, depending on the standard deviation, we can get in and still be reasonably accurate because we know how well we did. If we look at requests, this enables us to drill down. One of the things that I found this really useful at is if somebody's complaining that their website's running a bit slow, and can I run a load test on it to try and figure out what it is? Can I actually identify which actual resources are being really slow? So have they put a 5,000 megapixel bitmap on as a thumbnail? I know it sounds daft, but I have found that in the past. So basically, it just enables us to drill down, and we can see each individual request, and we can see which ones are running really fast, which ones are running really slow. We can't see anything that's failed at the moment because funnily enough, I normally run this and a few things fail, nothing failed this time. However, looking at the details view, we can now drill down and see into each individual test that was actually run. You'll notice these are coming up in two colors, so we've got 20% of our tests are actually coming up in purple, and these are our web test 1 coded tests, and the blue ones are coming up for our web test 1 tests. And it's giving us all the vital statistics, and we can scroll around this in a very similar way that we could to the other graphs, and you'll see if we go right down to the end, it stopped actually running tests because it knew it was going to finish. But here we can see the actual stepping, and we can see each individual test as it was run. And we can drill down, and if there's a test log available, we can actually get into the test logs. But it's basically, it's showing us, it's enabling us to actually analyze and double check our test mix method. So how we're actually running our test mix, we can actually ascertain if that's actually working correctly or not. And like I said, we can zoom in to quite a large extent, so we can almost take it down to individual test, or we can zoom out and we can view lots and lots of tests at the same time. It just enables us to actually see what's going on, and enables us to actually get into each individual test, and because we can get into each individual test, we can see exactly what's going on. There are also Excel reports we can produce, which I'm not going to go into at this stage, but essentially they enable us to actually compare different runs, and we can compare multiple runs, or we can do the whole lot. Okay, I think that's just about it. I've just got time for a few questions, which I'm sure Mel would like. Okay, I'm just going to go straight in. Okay. Which editions of Visual Studio 2012 contain web performance tests? Well, essentially, Ultimate and Premium now contain web performance tests. Previously, it was just... Let me just click through and we'll get on to the very last bit. So, any questions? So, essentially, previously in 2010, it was only available well, you could do web performance tests in Premium, but you couldn't do load testing. Load testing you needed to have Ultimate for. Now you can do load testing with Premium. as well. So, next one. How do you know if a test passes or fails? Do you need performance benchmarks first? Well, essentially, it depends how you mean by if a test passes or fails. There are certain thresholds that you can actually set in your run settings that will actually automatically fail the test if a certain number of errors or threshold violations actually come up. What you can also do is essentially based on a previous benchmark. So you've got your benchmark that you've done and you're comparing to your benchmark. If you're not comparing so if your system's not running as well at the same level, then you could say it's failed. It's very subjective. It really depends how much of the system has changed, how much they were anticipating actually losing performance. So you have to actually you have to take that on an individual test by test basis. How would you go about conducting performance and load testing on web services? Essentially, it's just like working with a performance test. What you can also do for web services and for performance tests, there's a utility you can download from Codeplex, although it has just been bought out by a private firm, but it's still on Codeplex available for downloading. And this is called Fiddler 2, which some of you may be aware of as a well-known network sniffer. Essentially, what you can do is you can actually record the interactions between your application and the web services, and then take that recording and turn that into a web performance test. That's one way of doing it. Or if you know what your schema is, you can just paste your schema in, and you can replace any actual parts that you actually want to data drive, for instance, with an actual context parameter. So you can get into your XML and replace parts of your XML with data from a data source or from that has been returned by a previous test. Essentially, it's not difficult to actually performance test an actual web services. Next question. Is load testing only possible for websites? Can it handle client-server applications? Actually, I believe I did explain this earlier. Yes, you can use unit tests. There's no automated way of actually recording an actual unit test to actually do it. But if you've got a good idea of what sequence a number of client service requests are going to be made in by any particular user, what you can do is you can code up a unit test to actually simulate these, and then you can run your unit test as part of a load test. Also, you can run unit tests to actually load test an API. So you can say, right, okay, well, I actually might have 50 processes all actually working with this API all at the same, asynchronously at the same time. Will it be able to actually cope with that many? Will it run into any problems with people running it simultaneously? So you can actually load test your APIs in the same manner. But yes, it can handle client-server stuff, but you can't record it. Okay, that's it for the questions that I've been given. Okay, I'm going to hand you over to Melanie.
Thank you, Ian. Once again, thank you for that lovely presentation and for that brief overview of web and load testing. Before we conclude this afternoon's session, thank you once again very much for today's training event, for joining us in today's training event. We hope you found the sessions useful and informative, and it just gives you a good understanding of VS2012 and how powerful the tool is for testing your different applications. Just before we go, just a few things I just want to cover for you. To find out how many free or funded support days your company has, please do contact us. I mean, for more information, please log on to our website, which is www.dtdps.com, and that should be able to give you an understanding of what funded or support that you have available from Microsoft. Again, we would be grateful, please, if you could provide us a reference at Microsoft Pinpoint. I will email you all the link after the training session this afternoon. In recognition to this, we will be giving away two £50 M&S vouchers to 2 lucky people chosen at random. So if you could do that for us, that would be much appreciated. Again, if you do have any further questions, please do type this in your Q&A pod. We'll leave the room open for the next hour or so, and we will, of course, endeavor to answer your questions promptly, either end of play today or even at early tomorrow morning. Once again, thank you for joining us for today's training. Any further questions, please do not hesitate to contact us. Thank you very much for today's training session. Thank you.